Hey everyone. So we're just getting back from break, starting up the class again. Did have a question. Can we configure to the front as shown to be the top view? Not quite sure what you mean in regards to that. Normally, I think what you're saying is, can we just run a horizontal machine as we would a vertical? Yes, and if you're going to do that, you would program just like you program a regular vertical machine, but you would set up the kinematics to represent the way that the address letters and the rotation values that you want. So I hope that answers that. If not, I guess try and give me a little more detail. Sure. Yeah. Again, if that doesn't answer the question, if you're still, if there's still something that you want me to expand on, shoot me an example. If you can, set up a zip-to-go file and shoot it over, or maybe an email with some more description. We will be happy to take a look at it. Mike asks a question. We just got a Doosan DNM350 with a Fanuc 0i control, and apparently it is a 4+1 machine, meaning it can only move 4 axes, any 4 as I understand it, simultaneously. We don't do a whole lot of actual simultaneous 5-axis toolpaths, but I'm wondering how exactly would I go about restricting the post to output 4+1? Is that handled in the post or in the 5-axis toolpath parameters? Really, I would say both, because since it is a 4+1 machine, you're going to want to set up the post output so it can handle 3+2 for sure. So for example, you should be able to rotate to any compound angle, but I don't think you'll be able to do it simultaneously. So for example, you can't do XYZ AB. You're going to have to do XYZ and then A and then B, or for example, XYZ-A, and then output B as a separate value. So for that, we're definitely going to want to modify the post to handle that type of output. Now, that said, there are certainly ways to restrict some of the parameters to only do a single axis. So for example, axis substitution is a rotary axis toolpath. There are some limitations to it inherently. So inherently, axis substitution only does a single axis of rotation, and it usually only rotates about the center. Now, there are some ways to kind of trick it. So for example, you can wrap geometry that has like a ramp to it so that it starts up above and feeds in, in Z as we're rotating the rotary. So that's kind of a trick where we're not just doing, we are rotating always about the center, but we're also simultaneously moving X, Y, and Z. Now that said, there are certainly some cases where the geometry itself is not constant in the radius value. So for example, you've got some surface that's out in space somewhere, and you want to be able to cut it with a simultaneous toolpath. Then we have to figure out either a toolpath that will just let us do one rotary, or we have to be able to break up the motion in the post, or in some cases, maybe if that's not desired, we should at least warn you if there is simultaneous rotation in both axes. So be happy to take a look at that. on an application side, let's get a little more info from you. So for example, well, actually, you know what? Let's look up the machine. To me, that's always first step when I go to look at building a post. Okay. D&M 350 5-axis. So, whenever I go looking for a machine like that, yeah, no worries. No. Just, do a quick search for it, and I can instantly see this is a vertical style machine with a trunnion. So it looks like it's got some kind of platen and probably an A-axis, just from looking at it and seeing that we're rotating what looks like on X. Machine for beginners in 5-axis machining, highly rigid C-type structure. There we go. Table size 350 millimeters, 40 taper tooling. 600, 655, 500 travels millimeters in X, Y, and Z. 12,000. Here we go. Rotating A and C. So the A has 150, A about X, C about Z, and 150 degrees of travel. Is that plus or minus 75? Or does it do like plus 30 minus 120 or something like that? Or minus 30 plus 120? Haha! Plus 30 minus 120. Perfect. All right, so let's set that up. So the only thing we have to consider when we're naming the files themselves, no slashes. So even though that looks like on Doosan's site, they show the slash there, we're going to either use an underscore or a dash. Okay, so we're going to do that. Okay, so we copy and rename the files. We start in Mastercam. Go to machine type design. File new. Make sure we're in design mode so that we can go to machine and open one up. Okay, so when we look at this guy, this is a Doosan. Space 350/5AX. Alright, so let's fix this guy. So what's on the table? Does the table just rotate or does it move in Y? Quite see that here. Or does the spindle move in X, Y, and Z and just the table just sit there? Table moves in X and Y. Okay. Perfect. So then we want spindle moves in Z. Perfect. All right. So then we've got the A, and we've got the C, and because we can't end in a rotary, we're going to need a mill rotary axis chuck. I know it's a platter, but actually, you know what? We can do this. We can just move the table below the C. Okay, X, Y, A, C, table. And that means we can get rid of these guys. Okay. And if we look at the A, it is rotating on X. 0 degree position is actually vertical. These don't matter because that's not done in the machine def. We look at the C. The C does rotate that way. Now, this is an interesting thing. We can set these values here, but they don't change the fact that we have to set them inside the machine. If we look at the A, we're rotating about X. The 0 degree position is positive. So X means that, say for example that we just wanted to rotate something so that our tool was pointing to the side. All we want is A-axis motion. If we go into the C-axis, in order for that to be true, the 0 degree position has to be located on X or Y. If we locate our 0 degree position on X plus, that means that whenever we rotate, we're going to have to get C-axis motion because there's no because of the way that the vector lies. So I'm going to put this at y plus, and I'll show you guys. I think I can show you what I mean with a practical example later. Let's get through this though. $12,000 RPM spindle. We got to set it in the post too, but I want to make sure I do that here. Okay. Edit the control definition. So it's the Fanuc OI. Posts. Okay, so let's look at the post. This is the one we've got linked. .nc for your file extension. I'm going to leave that there. If it's different, let me know. .fan.nc. Both or together. Like that. Or you're saying it can be .fan. Oh, gotcha. That's cool. Gotcha. All right. Probably do stage tools, arcs. We'll do delta start center IJK. 4-axis feed options. We probably want degrees per minute for this machine, unless it does support inverse time. Do you know if it supports inverse time? Oh, we'll try inverse. So 4-axis we'll use inverse, and 5-axis we'll use inverse for rotary, and we'll use units per minute for linear. You'll probably want the Safe Z retract option as opposed to the box option, honestly, because that'll just force it to go up to Z before it rotates. All the rest of this stuff should be okay. So we're going to save that. And in the defaults, we're going to go to the default setting. We're going to go to the NC Files page. I'm going to right click. I'm going to import all of the pages from the existing DoSon control. And we're going to grab them from this post that we set up. And when we do that, you notice it changes the file extension. So we'll save that. That means the defaults are set and the actual values are set, which is very important. Oh, you know what we want? I didn't save the description to the defaults. Save the defaults. That way our actual post has the right settings. Okay, so we've got all this set. Last thing, we make sure that the axis combo is set. Now that should be good. Okay, and should be good there. And how are we doing on time? Okay, we're getting there. Now we do the post config. Okay, so part of what we'll want, MR6, absolute safe height in Z for unwinds and tool changes. Limits must be enabled. Limits are, this is part of it. Enable retract to and from linear limits. This must be enabled, so MI7 must be 1 in order for that to work. And MI8 must be turned on. So MI8, miscellaneous integer 8, controls safe retract and approach at tool change. The tool retracts and approaches to the limits from the last path to the current path, or after and before a tool change. So limits must be enabled and use stock type. So with MI8, enable at null tool change, retract and approach only is a setting of 1. Enable tool change, retract approach only. So only when there's an actual tool change is number 2. 3 is enable both tool change, retract, and approach. So both would be null and actual. A setting of 4, enable retract and approach between 5-axis chains, which uses the cut pause variable, in the toolpath. Or sign 1 to 3 negative with tool change options. So 1, 2, and 3 can be signed negative, and that does something. And honestly, I forget what it does. We'll have to look at that. So we'll come back to those options. Let's do the base configuration here. What's the first thing we always set? First thing we always set is M type. You've got a table machine. It means both rotaries on the table. Primary is going to be C. Secondary is going to be A. We make the dummy B. So, what is our primary? Our primary is a Z. Does this make it output retract? Does this? What do you mean this? You're talking the safe retract? Safe retract actually outputs a Z coordinate as a Z value relative to your current work offset. It does not change between the G98 values or G28. So G28, correct. You got to make sure you don't over travel, or you have to modify the post to output reference point return. By default, you can force it to use 0 or 1 for MI3, which will give you a G28 or G30 reference point return. I would recommend modifying the MI3 table to use G53 instead of G28. That's what I typically do for the reference point return, but the reference point return by default will only be used at the actual tool change. So if you look at G28, for example, you just search it in the post, there is a string select table that will select between G28 and G30. And this is actually really easy to modify. So make it a G53. And we have to set this to 3. So doing that would mean that for MI3, we could use a setting of 2, and it would generate G53. The only other thing then is we have to make sure that when that reference return is called as G53, that we're not in the incremental. If we look at SG28 ref, that's the output. So here you can see there's the first occurrence of SG28 ref. So it's only used in this one place in the post. You can see that over here, they actually just force out G28, which is bogus. So, you know, we could do this. So if MI3 dollar sign is less than 2, we're going to output this thing here. We look at SG AbsInc here. SG AbsInc is used to output either G90 or G91, and it's based on the value of AbsInc dollar sign. So SG90 would output G90. SG91 would output G91. And SG AbsInc is going to output one of these two strings based on the value of this predefined variable. So what I would do is just use this SG90 here. And here, actually, it's a string, so we don't need to force it. It'll actually just output on its own. This guy is a string select function. So this one you can force if you want it to. But this will give you GO, G53, G90, Z0. And you notice it's now selectable. So if MI3 is less than 2, we're going to get G28, so GO, G28, actually, yeah, G0, G28, G91, Z0. So that's going to output G91. Now this is going to output G90. Okay. Okay, so that's how we would do that part. Let's get back to the configuration. Here we don't need to, because you notice there's no ABS Inc. call. So it's going to be GO, and this is going to give us G53. So, I mean, you know, technically we could change it if we wanted to, force G53 always. But that's really, this is only output at the tool change position too. So this, you know, if MI3 is 2, we're going to be in absolute mode because we've got SG90. So, you know, we could go back and change it. We could do a lot of things. Let's focus on getting the rest of this thing configured because we're almost done with class for today. Okay, so we go to M-type 0. Let's look at the plane here. We know we've got a Z-axis platter just by looking at the picture. Z-axis platter. Now, there's 4 different vectors we could choose for our 0 point. We know we want to rotate, basically to get to this side, we want to rotate minus 90 because we've only got plus 30 on the other side, and we've got negative 120. So we want to rotate here for minus 90. We can see that from the picture. So our 0 point, I'm going to make vec y, and I'm actually going to make it minus vec y. So minus vec y is our 0, and our direction has to either be minus vec x or positive vec x. We'll get to the 0 rotation later. Now, when we're talking about the secondary, our axis here is actually going to be positive vec z, and we're rotating about x. So this either has to be y or negative y. If we think about that in terms of the rotary of a part, let's do this. Okay, so we've got some kind of part sitting on our platter. And if we look at it from the right side, we're looking down the A-axis. Right, so in terms of the machine, we're looking down our A-axis. Positive rotation right now is set to plus vec y. So if I do planes, our right side is set to our tool and construction planes. So if I do rotate, so if I rotate that on the machine to 30, that's as far as I can go. And we can see that if this was plus, and we're rotating towards the plus side of y, that would be positive vec y in terms of our post here. So rotating towards positive vec y. If we made this negative vec y, and we were rotating at 30 degrees that way, and that was positive rotation, that would not be good. Because if we went negative 90, for example, and the cylinder was moved over to that way, that's the positive side of the machine. We can't go that far. So that tells me that this is the right setting, that positive rotation being that way, and we want to rotate negative. So this would give us our Z, this would give us our X. Now we'll go down to the pivot stuff. We don't want to use tool length. So to not use tool length, we just set use T length to 0, which tells it to use the tool length variable, and our tool length variable is already set to 0, so that basically shuts it off. Shift Z by tool length, we want to set to 2 because this is tooltip programming. All this stuff here is good for now. Now we'll get down to setting the limits for this guy. We'll go through the limit stuff in class, because we're just about out of time anyway, so we'll come back to some of this stuff. But right now, primary, now if we were going to do a live simultaneous cut by just positioning A and rotating C, that's when we need to know if the rotary truly is unlimited and continuous, or if there is an actual limit. So some rotaries will be truly unlimited, and if you go past 360, it'll just go to 0. Some rotaries have an actual upper and lower limit to the number of rotations they can do, and it'll either tell you it's plus or minus some big integer of a number, or it'll tell you the number of full rotations that it can do. So say for example, your machine can do 900 rotations. We would put in 324,000 as the plus or minus integer number. So we can make this right now plus or minus 360. Do you know if it's allowed to wind up? Okay, no worries. So you know what we'll do now is we'll just leave it. And what we're doing is we're basically telling it the primary can just wind up. It can wind up an unlimited, well, not an unlimited, 6 nines. If we divide that by 360. It's like almost 2,800 rotations. So the post will keep track internally if we are creating a simultaneous 5-axis path where we're winding up the rotary. The post will keep track. So if your rotary is unlimited and you don't want to encounter an error and you're doing some kind of live 4-axis rotary cut, then we need to enter an integer value that is big enough that it doesn't, complain to us. This post does have rotary logic in it for repositioning. And what that means is that if we go to an angular limit on either the primary or the secondary. So we've either wound up enough times to hit the primary limit, or we've got some kind of low limit on our machine. You know, sometimes you'll get a gantry and you'll have something like this. You know, my gantry's only got plus or minus 181 degrees. When you're dealing with a machine like that, a lot of times you have to tell it, okay, my machine, if it gets to within a half degree of this limit, I want to reposition. So in this case, for a more limited machine, we're going to say, all right, I can do a total of 181 degrees plus or minus. But if I get within a half degree of that, I want it to reposition. In our case, we're allowing it to wind up, so we're just going to leave these here. On the secondary, we know. The secondary limit here, and I think actually, hold on. If I look back at this guy, you know, it's telling me 360 degrees. Sometimes we can look in their literature and get the info we need. So let's just check that. Okay, XYZ travels. Rotary table. Oh, this is good info right here. Okay, so for the 350 travels, you've got plus 30, minus 120 on A. You've got 360 degrees on C. So we don't know if it can wind up yet. We're hoping it's going to tell us later. But it also tells us down here RPM, revolutions per minute. So the rapid traverse rate, the fastest this thing can go, is 20 RPM on the A and 30 RPM on the C at rapid. Now, the reason that that's important to us is that we can kind of glean from that not only the rapid travel rate in RPM, there is a conversion we can do from RPM to degrees per minute. So that will help us determine some of our feed rate limits as well. Okay. Dun, dun, dun. Cutting performances. See if there's anything else in here that tells us. Okay, so there's cutting feed rate. So at least 7,200 degrees per minute. That's good info right there. 590 inches per minute for the cutting rate. Okay. All right. Well, we know at least we can set these. So the limit 120, high is going to be 30. Intermediate, we're also going to set them to the limits here. And we probably do want to turn on automatic clamping and figure out what the correct M codes are for the clamping. For table-table spindle alignment, this is telling us when we have a table-table machine, how is the axes, how is the spindle aligned? In this case, it is Z+. And the machine base matrix is for a vertical, which is what we're currently set to. If you look at this column of numbers, it matches this here. All right, so that is the basic rotary axis limit configuration and all the other settings configuration for your machine, Mike. We're going to have to pick it up in our next class. How do we break up those rotaries? Because we really only had time to set this up for the table today. And that's okay, because there's this handles the basic configuration, and then we get into testing for the rotary motion. To give you a little heads up on what's coming, there's two things we really have to do in the post for that particular machine. At the tool change events, when we output rotary positioning, typically, whether we're doing a 5-axis toolpath or whether we're doing a 3-axis toolpath, there's always an initial positioning, right? So we're going to rotate the rotaries to their proper spot. Let's just do something real quick here. So if we go to PSOF, what we're going to be looking to do is find where the tool starts up, either at the tool change or the null tool change. So start a file, tool change setup. Basically, we can either, well, there's a couple places. So here, for example, is a line of code that outputs both rotaries. I can tell that because as I read across, we have pcan1, which is going to be our can text output, block delete on or off. So if block delete has been turned on, we're going to output the slash. If it hasn't been turned on, we're not going to output it. $$ is our sequence number. SG code is going to give us our G0. Then we have xabs_s, yabs_s. So we've got the mapped value of x, the mapped value of y, and then I see P out and S out. So for example, here we've got some rotary output. Now this is in mapping mode, for tool plane mapping mode. We have the else case, which is 5-axis and regular mode. And so if I go down here, again, I see P out, S out, and then I see the else case down here, which has P out and S out. And this is the primary and the secondary, and this is what we're going to want to break up. Now, technically, 4+1, I believe, means you can move any of the 3 linear and 1 rotary. Now, you may want to check and see if they will actually let you do X, Y, and then AC. I don't think that's the case. I think the way that Fanuc control is set up, it's basically 3+1 or 3+1. In other words, we can move X, Y, Z in A, or we can move X, Y, Z in C, but not A and C together. Now, if that's not true, if the control will actually let you do X, Y, Z, X, Y, AC, and not Z, then we can actually get away with the existing output, because you can see right here we're actually doing X and Y, and then we're doing the primary and secondary because later on down here is where we actually output our G43 with our Z move. Right, only 4, but will it let you do AC XY? That's the question. You can test it on the machine, I suppose. You know, tell it to move, you know, X, Y, A, and C at the same time. Yeah, so that's the real question. I know they say NE4, but as long as it really is NE4, then the post at the moment should already be breaking up your X, Y, and Z motion on approach and your X, Y, and Z motion on retract. Since that's the case, at least at the tool change, it should already support 4-axis only positioning, because that's the way that it's designed to do it. So yeah, check on Monday, and you know, we're at the end of class anyway, so we'll pick this up for our next office hours, and yeah, we'll get a little closer to building you a post, man. How can you check about C wind up? Program a move that's over 360. So program, for example, C 720 degrees and see if it makes two winds. And look at the position display on your machine. So if you program C 720, does it show C0? Does it show C 720? Does it show C 360? And do the same thing negative. I like Jeremy's comment, run it till it stops. Yeah, and same thing with negative. Give it a negative 720. The other thing you can do is, you know, program a large revolution. So, you know, program, you know, tell it to do 50 revolutions. You're going to be at rapid, so it's going to sit there for a while. But, you know, if you do 50 times 360, program C 1800 and see what happens, or C negative 1800. And really, the real answer is to pose the, yeah, watch out for overheating. That's a good thing to be aware of. Yeah, and that's the thing, is you really want to get together with Doosan. Just ask your applications engineer if there is the rotary axis unlimited, or is there an actual rotation limit on your C axis? So if you program, and now most of the times with a 5-axis machine like this, they don't have a turning mode. Some do. Some will have what's actually called a turning mode, where you can just say, all right, spin my C axis at 20 RPM. I think 20 RPM is actually your limit, or maybe it's 30. But, you know, spin my C axis at 3.258 RPM or something like that. I doubt this machine does. This machine probably only has a C axis address, and that's the other thing you need to test. Will it accept negative numbers? Oh, the Mori has the option, but not the Doosan. Yeah, it makes sense. So, will it accept negative numbers? Can you give it minus 20? Can you give it minus 180, minus 360? Or will it only accept values in the 0 to 360 range? And these are the type of questions you need to ask about any 5-axis machine tool that you're going to set up. So this is a good thing to see, and I'm glad you asked the question, because doing these practical configuration exercises, I think, really helps break down the barriers, the mental barriers that people put up for understanding how to set up a 5-axis machine. Yeah, please do. That'd be great, on getting the info. This post has been around since the late 90s. So, you know, this technology has been in Mastercam for a long, long time, and it can be very daunting at first. I totally get it. It scared me for a long time. And then I just kind of have done enough of them that it started to all make sense. And it's like, oh, okay, well, mathematically, here's what the post is doing to derive these angles. And I just need to give it the proper input, the proper setup, whether that is programming the operation correctly in Mastercam or making a configuration change to the post processor. I just need to figure out what those pieces of the puzzle are, and once we do that, we're off to the races. So, cool. All right, guys. Well, I think we're going to wrap up class for today. Well, office hours anyway. Office hours session. And so, thanks, guys. Thanks for attending and coming on and spending, precious time away from your family on a Saturday. So, glad you guys could make it. I always enjoy it. So thank you all, and we'll pick this back up on Tuesday. Okay? All right. Thanks, everybody. Go ahead and shut down the recording, and I'll wish you guys a wonderful rest of the Saturday evening, and hope you get to spend time with your loved ones, and wish you guys all a great night. Yeah. Have a great rest of the weekend, guys. So we'll see you guys again soon.